we're going to be doing a power adapter fix on this Gateway laptop. Now, if you look what happened to the adapter, the tip is damaged, and the inside of that tip, the plastic, is actually missing. It's stuck in the power jack on that laptop. So our first priority is to get that plastic out of there. And then we're going to need to repair the actual AC adapter. We're just going to replace the tip. And that's if the jack is okay. Once I pull this plastic out, we might find that the jack is not okay and we have to replace the jack. But first things first, I'm just using a small, like tiny set of screwdrivers. I think I got it $1 for $1 at Micro Center. I'll just pick the tiniest one there. And I'm going to use that and try to pry out the plastic that's stuck in the power jack. And I got it loose, and then I just grabbed a thin set of needle nose pliers and pulled out the plastic, and here is the culprit. Now the inside of that jack is clean, it's clear. I'm going to take my voltmeter out and make sure that nothing got damaged in that jack. I'm just going to see if there's any short circuits by setting the meter for continuity, which is where you hear that little beep. Most meters make a beep when you touch the two leads together. And I'm going to touch the inside pin of the power jack and a ground point. And if I hear a beep, then I know there's a short circuit and there was damage done to the jack. If I don't hear a beep, then I'm going to assume it's okay. And it looks like it's okay. So we're going to try a power adapter, a different power adapter in this machine, to see if it powers on. Now this is actually a blooper that I'm keeping in the video. We'll see how sharp you guys are. So I plug in the new power adapter, and I push the power button, and nothing's happening. Can you guys tell me why nothing's happening? You might have to rewind it to see it. Anyway, I'm going to fast forward this because I messed around with it for a while, wondering why it's not powering on. I even take off the hinge cover, inspect the button, take out a couple screws, try to figure out what the problem is. Everything looks okay, and then I realize I forgot to attach the part that plugs into the wall to the actual power brick right there. It happens. If you did spot that, good for you. So now when I plug it in and I test the button, we get power and everybody's happy. So it appears that the power jack is good, and we just need to repair the power adapter. Just wanted to show you I make mistakes too. Now to replace the tip on the power adapter. And this is the power adapter in question that we're going to fix. We're just going to cut that tip off. Make sure it's not plugged in as you do this. We're going to cut it off right at that point. We'll make sure all the wire below that point is good and there's no crimps in it or bends or breaks in it. Now I'm going to just take a little pair of pliers here and remove the outer casing from the wire there. It might be wise to use wire strippers, which I do not have right now, but it might be wise to use wire strippers just in case you don't cut that wire and break it. But my trusty little blue snippers do okay. Just don't put too much pressure when you close it. Now we're going to wrap up that outside ground wire, which is the bare wire. And once we're sure that those wires are not touching, we're going to plug the AC adapter into the wall and test to make sure we're getting the correct voltage to those wires. Now I didn't do it with the bad tip on it because the tip is bad. So now that we remove the bad tip, we're going to be able to check if this adapter is putting out the proper voltage. So I'm putting the black on the bare wire and I'm putting the red onto the white wire. And it's slowly giving us a charge, which is not a terribly good sign. It may be my voltmeter is acting a little flaky. Battery might be running low. So let's try that again. Or the wires were loose or something was loose. We'll give it one more try. If it does that again, the power adapter might be a little flaky. It might be on its way out. It might not be able to put out the amps that it needs. And that time it goes pretty much straight to 18. Now sometimes those power bricks take a little bit of time to charge, but that usually shows a sign of weakness when that happens. You're also going to notice the part coming out of the power brick is frayed as well on this power adapter. So that's going to need to be repaired too. I have another power adapter here up on the bench I'm testing as well as this one. And I'm just going to pick the stronger of the two, which turns out to be the one that doesn't have that frayed part coming out of the brick itself. Just make sure that the voltages and amperages match up on your power adapters when you're matching them. So I'm going to bring out the heat shrink tubing here. I use heat shrink tubing instead of electrical tape because it forms a bond. It makes it more professional and tougher for the customer to peel away the work that you did. And I'm using a Radio Shack adapter plug here. And this is going to be a little bit of a crude way of doing the power adapter repair, but it's pretty solid and it makes a good connection. So I'll show you what I'm doing. Right now I'm going to sand the leads that go into that adapter plug. See, that adapter plug is meant to be plugged into another adapter. And it gets really expensive at Radio Shack when you start buying adapter upon adapter. So sometimes I like to solder the leads for the power adapter directly to the leads on the adapter plug. But since they aren't meant for solder, I'm sanding them off, I'm scuffing them up, so that when I do solder the leads to that adapter plug, the solder makes a great connection. It's strong, a good bond, which won't break. Let me just zoom in here so you can see what I'm doing. Notice that's a size N adapter plug. That's a pretty popular brand, a pretty popular size. Most gateways, Toshibas use a size N. And I'm just scuffing the metal of those leads. So when I drop some solder on there, it'll stick really well. Now I'm going to pull the soldering iron out. This is the soldering iron I use. As you can tell, I like Radio Shack. They're not the cheapest, but they always have what I want. And I'm just using a piece of Scotch-Brite there to get the remaining solder off of the soldering iron. If you see it in the soldering iron holder there. And basically what we're going to do is attach those two wires to those two leads on the adapter plug. I'm going to expose some wire on the white lead there. Now again, you have to sand these wires, both the ground wire and the positive wire. You need to sand them because the little wires in these power adapters are coated. And solder doesn't like to stick to that when they're coated. There's little strands in there that are coated. And you'll notice once you sand these wires on these power adapters, if you're doing a repair like I'm doing, you're going to start to expose copper on the wires. When you start to see copper on those wires, then you know you're getting that coating off and the solder will stick very readily to the copper. So it's going to be tough to get solder to stick to these wires unless you do what I'm doing now. Sand the strands of wire inside the power adapter lines there until you see copper. And once you start to see the copper, you'll know that your solder is going to stick and make a good bond and not break off. Okay, now that that's done and we have some copper exposed, we know that our solder is going to stick. Just make sure you get enough of that copper exposed that you're confident your solder job is going to be okay. Okay, now here's what I'm talking about. Those are the strands of wire that I was sanding, and you'll see a tinge of copper now on those ends of those wires because I sanded it. Now we know our solder will stick. If we didn't do this, you'd have a tough time getting solder to stick to those wires, trust me. You might be asking now, why don't they just buy a new power adapter? Well, you could do that too, but if you want to learn how to do this, I'm showing you. And I'm going to grab a little device called Helping Hands. It allows me to place objects in there. It's just a pole with 2 alligator clips on it. It allows me to place an object in there, and it actually acts as an extra set of hands, which I do not have. And I'm going to just put that adapter plug in there. Going to zoom in and help you get a good view here. Going to add some solder and just tin the edges of those adapters there, or those leads there. Just put some solder on each one of those leads. I like to melt it on there so it's all melted on there. You can see how the solder's on there. Now I'm going to do the same thing with the leads for this power adapter. Now please note, this power adapter is unplugged at this point. Do not work while it's plugged in. I only plugged it in to test the voltage, and then I unplugged it. Okay, we're going to take a big piece of heat shrink tubing. I'm going to cut a little size of it off. And I'm going to put that around our wire. Now that's a real big piece, real wide, but we're going to need at least one wide piece to get around the adapter plug. Then I'm going to use a thinner piece just to shield the connectors. Again, this is somewhat of an unorthodox way of doing a repair on these power adapters, but it makes a sturdy bond, and I've done it a few times in the past with no problem. So make sure you get your heat shrink tubing through your wire before you do any soldering to the actual adapter plug, otherwise it will be too late. Okay, so let's get some solder on the end of those leads there. Also, again, this is the way I like to solder. I like to tin things with the solder before I actually solder them. And I'm just globbing some solder onto the end of that lead there. And I'm doing the same thing just on the end for the ground wire. Now, the adapter plug and these leads both have solder on them. Now, what I like to do now is just stick them together, heat them up, and let the solder melt into each other. I need to make sure that which wire is which on the adapter plug, which one is ground and which one is positive. So I'm using my voltmeter to test that. I'm just holding a lead to the outside of the tip and then testing which lead's positive and negative. And once I know that, I'm going to be able to solder that ground tip to the ground wire. Just want to test it there. See, I'm touching the ground wire to the outside of the tip, and I'm touching the positive the inside of the tip. I've heard a beep on both of those. You can't hear it because the clip is muted, but we heard the beep on both of those, so we know that the connection was proper. Or at least we heard the beep on the ground one. We didn't solder the positive one yet. The ground wire is the unshielded one. Now we're soldering the positive. Now, since I tinned both sides, all I have to do is heat it up, let the solder melt into each other, and it's a done deal. I'm going to show you here a close-up of what exactly I did, if the camera decides to focus. There we go. Get the idea? Now I'm going to take some electrical tape and shield some of the wire before I put the heat shrink tubing over it. There we go. This is good to do it just in case the heat shrink tubing gets worn down a little bit. You don't want any bare wires exposed. So I'm going to pull that heat shrink tubing up over the connector. And so far, so good. Now, the way to melt heat shrink tubing properly is with a hot air gun. I've used a lighter my whole life. It's just the way I do it. Some people might criticize it as not making an even heat connection. It's going to be a little lumpy, but it does the job fast. It doesn't smell that great. Try not to inhale those fumes. I think I have my dad to blame for showing me how to do it with a lighter. We never used a heat gun in my house for heat shrink tubing, but that would probably be the best way to do it. You'll get a more even bond. It'll melt evenly into the wire. And as you'll see what happened, it shrunk. And it shrunk around the wire, and it's forming a really hard plasticky type of bond now. Now, I like to put this thick one over just to cover the edge of the adapter plug, because if I didn't, you would start to see some bare wires showing as the more the power adapter got use. And this is a little out of the frame. Sorry about that, guys. You'll see the finished product, though. Sometimes I get too into what I'm doing and I forget that it's on the camera. Again, if you can help it and you want to use a heat gun, go for it. And you just want to make sure everything's melted evenly. It's not going to be the prettiest thing in the world when this is done, but it'll be solid. It'll work, and most of the time that's what the customer wants. I got a little fan there I used to cool it down quickly. And we're going to hit it one more blast here, I think. Get it all melted evenly. Here's another trick. You could use the barrel of your soldering iron. I think my little lighter actually ran out of fluid. You can use the barrel of your soldering iron and just kind of paint the heat shrink tubing as it melts. Try to be as even as you can. Don't let it sit there for too long of a time on a specific piece. This is another thing I might be getting criticized about, but hey, it works. I do what works. You know, Eddie Van Halen never took a guitar lesson, and he's one of the best guitar players in the world, so sometimes unorthodox techniques work all right. And again, we're going to cool that. Oops. It's not the best fan in the world. I can't tell you the number of times that blade actually popped off like that. Okay, it's a little lumpy, but it's not too bad, and that is a solid connection. You know, as long as you sand or scuff up the leads before you solder them and make sure it's making a strong solder connection, you're going to be okay, and you're not going to get returns on these. You also might be thinking, this is taking a long time. Is it really worth it to do this? Well, it depends. It's up to you to decide that. Now, I've got the voltmeter on. I'm touching the black to the outside, positive the inside. We should be getting 19 volts out of this. And there we go. 19 volts. Remember, do not touch those two leads together as they're touching the power adapter. You don't want to create a short circuit. So we're good to go. There's the finished product. Not too shabby. It has character. I'm just going to make sure no bare wires are being exposed. Do a little couple finishing touches here. And now it's time for the moment of truth. Always make sure before you actually test these in the computer that you test them with your voltmeter first and determine there's no short circuit. Okay, we're going to plug that in. And we're getting the purple light showing the battery is charging. So the adapter's working good. Battery light went out when we removed the adapter. Let's plug it back in. Battery light goes on again. Jiggle it around, make sure that the battery light stays on and it continues to get power. And that's a done deal.